Still on page 4. I'm going to look at question 10 now. And again, because of not enough room, working on a separate paper, I've just copied the problem here. And we need to simplify each of these square roots and see if we wind up with like terms so that we can actually do some adding. So carefully keep that x squared over here. It's a square root, so we're looking for a perfect square to come out of 45. If we divide by 2, you get a decimal. Divide by 3, you get 15. Can't divide by 4 without getting a decimal. But 5 helps us. Divide by 5, you get 9. 9 times 5, 45. That's a perfect square. That's going to come out. The x, just keep that x. That's not going to change. And the square root of v squared, we can change that to a v in a little while. In the other square root, 5 is not going to change. X to the 5th, I want to get the biggest possible power of x that's divisible by the invisible 2. In other words, biggest possible even power. So there we go. X to the 4th times x replaces x to the 5th. So that's going to change. And let's make these changes. We have x squared times 3 times v, and still under the radical 5 and an x. In the second expression, got that 6v out in front. This becomes x squared. Not because we're taking the square root of the 4, we're dividing the 4 by 2. Okay, so we get 6v x squared. Still under the radical, we have 5 and x. If I clean this up a little bit, maybe put the 3 out in front, write 3x squared v square root 5x plus 6x squared v. So you put the stuff in order and it's easier to compare them. Do we have a perfect match? Yeah, x squared v square root, same index, square root 5x. So 3 of these monstrosities plus 6 of them gives us 9x squared v square root 5x. We had 3 of those plus 6 of those gives us a grand total of 9 of those. Let me tackle